Alright, reprinted these bad boys, or redesigned, another redesign of it, with a slight flange here at the bottom on the inside, so it'll taper these tubes into place. So we have effectively eliminated the shaky, move around center electrode here, where it was just wobbling all over the place, and it's a lot more stable now. So this is acceptable. We have good tolerances all the way around, and these are the way they should be now. So I'll rather slap them into a cell and test it, but first I need breakfast because I am starving. So yeah, there it is in all its glory. Quick comparison. Damn, look at that boy. Alright, see what she can do. Well, we'll chalk this up to another math miscalculation here. I should have maybe chopped that another 1/2 inch so I could see the production that's being made. We're gonna have to just rely on maybe like the back feed of bubbles and our meters here, and bubble meter here to really see what kind of production we're getting. That sucks, but because I really like to see the production, but we'll just have to measure it empirically. Alright, going to be doing some rudimentary tests here. We have one cell hooked up, all fresh water here. This is my standard 4-inch cell. We are pulsing at 724 hertz, 85% duty cycle. Our consumption's about 8 amps. At our 29 volt input, 34 volts at the cell, 1.7 amps consumed. You can see we do have production there, not enough to really move the meter, but nonetheless we do have gas production there. This is our waveform. These are our unbalanced inductors, so we still have yet to balance the inductor on here. It's about half the value that it should be. Therefore, you see this offset of, not equal opposite polarity, but we do have opposite polarity happening. In comparison, cell number 2 hooked up by itself, 35 volts. The same voltage, lower amperage, and lower input consumption amperage. Still the same frequency, and maybe just a tiniest bit more production than previously. This is 2 cells in parallel. There's amperage and voltage. I believe that is a lower voltage than previously. We were getting, I believe, 30 to 35 volts. Amperage may be just a little bit higher too. Alright, 3 cells connected in series, brings amperage down to 0.7 amps. Got 78 volts across the cells, down to 4 amps input consumption, which is really interesting. Frequency, you can see this waveform here. We have higher voltage obviously, but kind of missing that equal opposite polarity and just kind of flatlining. It's probably because of the imbalanced inductor again. Our gas flow meter here, about probably the same amount of gas as previously. So if anything, if we're producing the same amount of gas on one cell as we are on 3 in series, but we have lower amp consumption, that's a win, because extrapolating this out, we get, I guess, at least the same amount of production versus one cell, but we have a much lower amperage consumption as a whole of the whole apparatus here. Previously, I had made the assumption, or I had the educated guess, that for each cell I added, it would double the voltage. That does not seem to be the case here. Whereas, you know, we get higher voltage for each one we hook up. However, it is not double the voltage. There is voltage loss for each one that you know, piggyback from. So, you know, if we get 40 volts on a single cell, we could probably get 70 volts on 2 cells, let's say, and 100 volts on 3 cells. So we do get higher voltage, but the voltage does not double as previously thought per each cell added. I want to be clear on that. That was my fault for, I guess, trying to extrapolate that voltage out. We are getting higher voltage here, period, with this setup, but we are not getting double the voltage per each tube that we add as previously thought. But here again, if we're making the same amount of gas or greater and we're reducing input consumption, let's stack as many of these as we can to see how low we can get input consumption for that amount of gas that we're creating.
This is Stand Revenge.
Alright, but now for the meat and potatoes, we've got the new 7-inch cell hooked up, valve check. Alright, we got an easy 40 volts at the cell. Still 1.7 amps, still chewing 8 amps. Unbalanced inductor. We had to take the frequency down to 555. I mean, I really can't see nothing in here, but I assume we're producing because we are getting bubbles here. You can see that. I'm not sure if that's any more gas than what we were producing. Now I had to reduce this frequency down because of the change in the tube size and gap. I'll have to jog my memory here. If capacitance goes up, does that mean frequency goes down, or vice versa in the LC circuit? So I need to do some maybe calculation on that. Not really impressed so far. You know, 40 volts is good on the cell. You know, I was getting like 35, 36 in that one, so it'll get a little higher voltage. And I mean, with gas production peaking here, it might appear to be just a little bit more gas than what I had previously been making, even though this does not appear to be moving at all. This water is already just murk, as you can see. Certainly not enough water in the cell given the size of the tubes. I'm wondering if these bubble backfeed inside the tubes could aid in perhaps ionization or something of that nature. There's a lot of thoughts here on what's actually going on inside the cell when there's hydrogen oxygen inside the cell rather than water. These are pretty much just pumping out as fast as they can go, where this is like just not enough water baths, so we got a lot of that recirculating through the cells, and I'm wondering how that's affecting it. See how quick this contaminates here. I really wish you could see it, but all you can see is just kind of that backflow. How quick that saturates that cell. So yeah, unimpressed with my results. Really need to balance this thing. I'm gonna have to balance this thing before I think I move any further.
This is Stand Revenge.